The little r is going along the parabola here. So the little r is our axis, our top, because our axis is our top. So it's 8 minus, well, wherever that thing's going to. It ends up being the parabola here. So our 2x squared. So as far as we're concerned, is for our integral is still going to go from 0 to 2. We got our pi out front. Our big R squared is our 8 squared minus our little r squared, which is 8 minus 2x squared dx, squared. So big R squared minus little r squared. Figuring out what the r squareds are is the hard part. Alright, let's do one more here. Alright, so we got the line y equals -2. So I'm going to keep everything back in normal size. Well, so our normal graph went here, here, and then up all the way up to 8. So we've got our parabola. We've got our function here. We've got it here. So we're still thinking the same area, the same rectangle. That's not changing when we revolve it around different parts. What's changing is what our big R and our little r. So our big R is the farther end of our rectangle to the axis. This is our big R right here. Our little r goes from the close end of a rectangle to here. So big R is actually hitting the parabola, and little r is hitting the line y equals 0. So in this case, if I want my big R to be positive, I take my top, which is our parabola, 2x squared, minus the bottom, which is a -2, makes it a +2. My little r, think of a top minus bottom again. So little r, the top of little r is 0, minus a -2, +2. So like usual, got our pi, bounds, 0 to 2, and then we're going from big R to x squared plus 2, big R squared minus little r squared. Plug and chug, get an answer. Now the next one, x equals 2. What you really have to do for that is, well, let's draw it out, see what happens. This is one of those things that we're going to learn something next, which is really going to make this problem a lot easier, and you're not going to ever really want to do it this way again. So if I want to revolve it around x equals 2, I really want to think about this, everything going sideways here. We have our rectangles, but they're sideways rectangles. Now, so we're only looking at this area here, and I don't have really a gap. Our little r is just going to be 0. So our big R is from here to here. So that's our big R, which is our parabola minus 2. Or actually, we want to think if we're going sideways, right minus left, 2 minus a parabola. However, our parabola is in terms of y. So y equals 2x squared. So if I solve for x, we got y over 2 equals x squared. X is going to be plus or minus the square root of y over 2. Now the positive is going to be the right half. The negative is going to be the left half. So I don't really care for the negative side because that's not what I have in my picture. That's not what we're looking at. So that's actually the function that we want to be looking at, is our x equals. So we'll talk about how we can do this. It's called the shell method. Instead of writing everything in terms of x's, or in terms of y's really, I could do them in terms of x's. So to do it in this form, our big R, we want to think more right minus left, is 2 minus our function, our square root of y over 2. And our little r is right minus 2. So 2 minus 2, or 0. So there is no little r, it's just 0. It's because it's pressed up against the axis that we're revolving around. Because again, we're revolving around this axis right here, the x equals 2 line. So with that being said, once we're there, that's not bad at all, except for the fact that we need our bounds if we're going to have everything in terms of y's. So 2 minus the square root of y over 2 squared minus little r, 0. If I have everything in terms of y, I need to make sure my bounds are in terms of y. So the lowest y bound is 0, and the highest y bound is, I think I mentioned earlier, would be 8. Is up here where my graph equals 2. So if x equals 2, if I plug in 2 here, I'm going to get 8 for my y. So if we do everything in terms of y, I'm going to make sure that my bounds are in terms of y. So I can't use my x bounds if I've got y's in the problem. It's not that much of a fun problem. We'll have an easier way of doing it later on. But that's how you can do this problem in terms of just the disk and washer method.